In this video, we'll see how to convert an array into a heap. We'll see two methods for doing this. One uses the top-down approach, the other uses the bottom-up approach. In this method, we'll call restore up procedure, and in this method, we'll call restore down procedure. So first, let's see this top-down approach. We'll consider that the array that has to be converted to a heap represents a complete binary tree. We'll call restore up for all elements from A2 to AN. Now let's take an example. Suppose this array has to be converted to a heap. So we'll consider that this array represents a complete binary tree. Now we'll call restore up procedure for all elements from A2 to A12. First we'll call restore up for this one. Parent is smaller, so 33 goes up and 20 comes down. We call restore up for this one. Parent is bigger, so nothing has to be done. We call restore up for this one. Parent is bigger, so again nothing has to be done. Then we call restore up for this one. So 20 comes down, 33 comes here and 40 goes here. Now we call restore up for this one. So 15 comes here, 40 comes here and 60 goes up. Now we call restore up for this one. So 40 comes here and 45 goes here. Now restore up is called for this one. So 16 goes here and 6 comes here. Now restore up is called for this one. So 16 comes here, 33 comes here, 60 comes here and 75 goes here. Now we call restore up for this one. Parent is bigger, so there's nothing to be done. Now we call restore up for this one. So 20 comes here, 60 comes here, 75 comes here and 80 goes here. Now we call restore up for this one. Parent is bigger, so there's nothing to be done. So now this array has been converted into a heap. Now let's see the bottom up approach. As in top down approach, here also we'll consider that the array that has to be converted to a heap represents a complete binary tree. We'll start from the first non-leaf node and call restore down procedure for each node of the tree till the root node. Now if the root node is stored at index 1, then the index of first non-leaf node is given by this value floor n by 2, where n is the size of the heap. Suppose this value is x, it means that we have to call restore down procedure for elements from ax to a1. Now let's take an example. Suppose this array has to be converted to a heap. So we'll consider that this array represents a complete binary tree. Now this is the first non-leaf node. So we have to call restore down procedure for all elements from a6 to a1. First we'll call restore down for this one. The child is smaller, so there's nothing to be done. We call restore down for this one. 80 goes up and 40 comes down. We call restore down for this one. 75 goes up and 6 comes down. Then we call restore down for this one. So this 60 goes up and 15 comes down. Then we call restore down for this one. This 80 goes here, 40 goes here and 33 comes here. Then we call restore down for this one. So this 80 goes here, 75 goes here and 20 is placed here. So now this array has been converted to a heap. Now let's see the program for both the approaches. We'll convert this list A1 into a heap using bottom up approach, and we'll convert this list A2 into a heap using top down approach. So now let's see these functions: build heap bottom up and build heap top down. In this function, we have used top down approach to convert this list A into a heap. We have called this restore up function for all the elements from A2 to AN. And in this function, we have used bottom up approach to convert this list A into a heap. So we have called this function restore down for all the nodes starting from the first non-leaf node till the root node. And we have already seen these functions restore up and restore down. So now let's run this program.